Hello everybody, let's work on 2.6, problem 3 here from the notes. A suspension bridge with weight uniformly distributed along its length has twin towers that extend 75 meters above the road surface and are 400 meters apart. The cables are parabolic in shape and are suspended from the tops of the towers. The cable touch the road surface at the center of the bridge. Find the height of the cables at a point 100 meters from the center and assume the road is level. So the key thing to this problem is taking the time to draw the picture. There's more than one picture that you can draw, and so please take a moment to hit pause and come up with some type of drawing. Alright, I'm going to still show you two, and the first one I'll draw is the one where the parabola is centered at the origin. And so we know that the towers are 75 meters high and they're 400 meters apart. So then that will make this one be negative 200. And so this ordered pair, negative 200, 75. And then this one will be positive 200 with ordered pair 200, 75. So our parabola will look like this. They're a little bit better. Alright, so the other one I want to draw is going to be so that one of the towers is on the y-axis. So this will be the ordered pair 0, 75. And since the towers are 400 meters apart, this ordered pair is 400, 75. And the vertex will be in the middle, so it'll be at 200 and then comma 0, or let's just leave the 200 there. So this is the vertex. And so our curve will look like this. And so the key to this, the reason why it's important to just take that time to draw the picture is in Calc 2, you're going to have to draw diagrams based off the situation. And there's like where you orient the origin can make a difference. It can make the problem a little bit trickier or a little bit more straightforward. So getting comfortable with seeing different types of drawings and then comparing to see which one is more efficient can be pretty helpful. And so what we want to do with this problem is we want to find the height of the cables at a point 100 meters from the center. So with either drawing, we would want to find the y value when x is 100. But over on this curve, it's going to be a little different because it's 100 meters from the center. So this would put it at 300. And you're still looking for that y value. And so in order to do this, accomplish this, we need the equation of the curve. And so when I look at this curve, because it's centered at the origin, like that general form in like the completed the square form is a times x minus h squared plus k. So this is like that general form of completing this of, like you can maybe say it's vertex form, but if you have your equation in y equals ax squared plus bx plus c form, you can complete the square and get it to look like this. So your vertex is hk. And so since our vertex is the origin, we don't really need the h and k here. All that we're worried about is a. In this curve, we have a horizontal shift, so we need to adjust that part of the function when we go to create it. So for that reason, I really like to stick with the one that's through the origin, because I'm going to use this fact to find a when I know y equals ax squared. Whereas on this one, I have to set it up as a times x minus 200 squared plus 0, and then I'll still need to find a. So this one's just a little bit more straightforward. Alright, so the way that we're going to find a is we used the vertex to be able to get it this far. We can choose either of these ordered pairs to solve for a. So I'm going to go ahead and use 275. And then solve for a, so a is going to equal 75 over 200 squared. And this comes out as a decimal. It is 0.001875. And so my equation is y equals 0.001875 x squared. Alright, and again, same thing over here. You can pick either ordered pair, plug it in, and solve for a. So I'm still just going to stick with this form. You're going to get the same answer if you use this one. Okay, so the question is asking what is the height when x is 100, so I can plug in x equals 100 right now. And then, oh, that looks terrible. And then we'll get y equals 0.001875 100 squared. And this is just going to boil down to moving the decimal place 4 places. So the height will be 18.75 meters. And that's our height. So you can use either form, you'll still get the same answer. So when you're 100 meters from the vertex, the height on the height of the cable is 18.75 meters. All right, I'll see you in the next problem.